The Y-20 stands as China's first heavy airlifter. Its noticeable similarity to the C-17 Globemaster.
China set out to build a heavy airlifter that could rival the world's best, but the moment the Y-20 took flight, one flaw quietly shaped its entire future. The engines meant to power its ambition held it back instead, forcing a redesign that changed everything and left a bigger question unresolved. What happens if the fix still isn't enough? A clone with a secret. When China unveiled the Y-20 Kunpeng, it framed the aircraft as a bold leap into strategic airlift, its own answer to America's C-17. The silhouette alone told a story. A broad, muscular fuselage, a tall T-tail, 4 engines slung low under high-mounted wings. It looked every bit the part of a modern heavy lifter, a machine built to move battalions, armor, and ambition across the map. But beneath the familiar outline was an uncomfortable truth that lingered for over a decade. The aircraft's power came not from an advanced Chinese turbofan, but from a relic of the Cold War, Russia's D-30 engine, a low-bypass design dating back to the 1970s. That choice was not cosmetic, it was crippling. The D-30 lacked the thrust a heavy airlifter needs to haul real combat loads, yet it remained the only option China could mass produce. On paper, the Y-20 claimed it could lift 66 tons. In reality, the old engines slashed that figure the moment fuel and range were factored in. The mismatch between ambition and capability created a quiet engineering embarrassment, a plane that looked like a C-17 but could not perform like one. And the deeper the comparisons ran, the more glaring the limitations became. Copying the shape, missing the muscle, line up the silhouettes, and the resemblance borders on uncanny. The C-17, the IL-76, and China's Y-20 share the same high-wing stance, the same swollen cargo fuselage, and the same T-tail geometry that signals heavy lift intent. To an untrained eye, the Kunpeng looks like it belongs in that lineage, a peer among proven global haulers. Even the landing gear arrangement, ramp contours, and wing sweep echo the designs that came before it. Engineers clearly borrowed what worked, blending elements of the American and Russian platforms into a hybrid crafted for rapid deployment missions. But matching the outline does not create matching performance. The Y-20 gained a nickname among crews, Chubby Girl, because it looked ready to carry anything thrown at it, while often lacking the power to back up the promise. Heavy lift aviation is not determined by how intimidating a jet appears on the runway. It is decided by what happens when weight meets thrust, when altitude robs an engine of air, and when fuel calculations determine whether a mission succeeds or never leaves the ground. The Kunpeng's problem was simple. China replicated the look of a world-class airlifter without replicating the propulsion technology that made those aircraft legendary. The C-17 silhouette is backed by extraordinary thrust and efficiency. The Il-76's rugged design is matched with engines built for demanding operations. The Y-20's borrowed frame, however, sat atop engines that belonged to a different era entirely, leaving China with a plane that looked fierce but flew restrained. The mission the Y-20 was built for. The Y-20 wasn't designed for parades. It was built for one of the hardest missions in modern military logistics, moving China's army fast. Across the Taiwan Strait, speed and mass are everything. The PLA envisioned waves of paratroopers, armored vehicles, and rapid deployment units flown across the narrow stretch of water before defenders could react. The same urgency applied in China's west, where high-altitude airfields near the Himalayas demand aircraft capable of hauling armor into thin air and rugged terrain. These missions require real strategic lift, heavy payloads, long range, and reliable thrust in unforgiving environments. On paper, the Y-20 promised exactly that. Its cargo bay was wide enough for a main battle tank, its ramp angled for rapid loading, its structure rated for serious weight. But numbers written in brochures ignore the realities of air density, fuel burn, and the brutal arithmetic of payload versus range. When crews loaded the aircraft for the missions it was meant to execute, the limitations revealed themselves immediately. Altitude stole thrust. Heavy armor consumed payload margins. Fuel requirements shrank operational radius to narrow circles around the departure airfield. A plane that should have projected power ended up restricted to short hops whenever real combat loads were involved. The strategic vision remained intact. The hardware supporting it did not. The Y-20 was built for long-reach missions, but the engines kept it from reaching far at all. A 1970s relic dragging a modern jet. The heart of the Y-20's struggle sat beneath its wings, 4 Soloviev D-30KP-2 engines. Designed in the 1970s for the IL-76, the D-30 was never meant to power a modern heavy lifter. Its bypass ratio, just 2.4 to 1, told the whole story. It pushed only a thin ring of cool air around its core, producing modest thrust while burning more fuel and generating more noise than contemporary turbofans. Each engine delivered roughly 12 tons of thrust, barely enough to get the Kunpeng airborne with anything approaching a combat load. In a perfect world, China's engineers would have installed newer engines from the start, but developing high-bypass turbofans proved far harder than copying an airframe. So, the Y-20 flew with what was available, not what was needed, and because thrust dictates payload and range, the consequences were severe. The aircraft might have been structurally capable of lifting 66 tons, but with D-30S, that figure collapsed in operational settings. Once you accounted for fuel and distance, the practical payload hovered around 55 tons, below the weight of China's own Type 99A tank. The mismatch created a quiet but undeniable embarrassment. A strategic airlifter that couldn't haul its primary armored vehicle wasn't fulfilling a strategic role. Instead, crews were forced into compromises, strip armor, reduce fuel, shorten routes, or abandon heavy lift missions altogether. Meanwhile, the engines groaned at the limits of their performance envelope, a stark reminder that power plants, not fuselages, define heavy aviation. The Y-20's body said global airlift. Its engines said local shuttle. And until that changed, the aircraft remained a heavyweight, trapped in a lightweight's reality. Why the C-17 became the gold standard. To understand why the Y-20 fell short, look at the aircraft it tried to emulate. The C-17 Globemaster III doesn't just resemble a heavy lifter, it defines one. Its strength begins with 4 Pratt & Whitney F117 engines, each producing roughly 40,000 pounds of thrust. But it's not just the raw power that sets them apart, it's the efficiency behind it. With a bypass ratio near 6 to 1, the F117 moves a massive volume of cool air around its core, delivering high thrust with lower fuel burn and far greater reliability than older designs. This combination turned the C-17 into a global mover capable of crossing continents with armor chained to its deck. That power translates directly into capability. The C-17 can take off from short, rough airstrips, back up under its own power, and deliver tanks, helicopters, or humanitarian cargo into environments that barely qualify as runways. Its engines have accumulated more than 17 million flight hours, proof not of marketing claims, but of durability forged in countless missions across Iraq, Afghanistan, Antarctica, and disaster zones around the world. Every sortie added to a reputation built on results. Payload delivered, mission completed, crew confidence unwavering. The C-17 became the aircraft other nations measured themselves against because it solved the hardest problems of airlift, range, weight, and reliability without compromise. China copied the silhouette, but the C-17 silhouette is only powerful because its engines turn that shape into performance. The Globemaster earned its status through decades of proven work, something even the most modern airframe cannot replicate without an engine to match its ambition. When the payload outweighs the plane, the Y-20's greatest test was always going to be whether it could carry China's heaviest armor. The Type 99A, fully equipped for combat, weighs about 58 tons. That number alone becomes a deal breaker when you compare it to the Y-20's real-world operational payload, roughly 55 tons when using the old D-30 engines. The math doesn't bend. A tank intended to spearhead modern ground warfare simply outweighs what the aircraft can reliably lift if it needs to fly farther than the next airfield. This mismatch created a logistical paradox. Load the tank at full weight, and something essential must be sacrificed. Armor plates removed, fuel drained, or operational range slashed to the point of irrelevance. Each compromise defeated the purpose of strategic airlift. If the tank cannot arrive ready for combat, or cannot be flown to the front line without repeated refueling stops, then the airlifter becomes little more than a symbolic transport platform. For PLA planners, this wasn't a theoretical inconvenience. It undermined doctrine. China's rapid deployment concepts rely on flying armor into contested or high-altitude regions before ground routes become blocked or too slow. But when the Y-20 cannot haul its own nation's frontline battle tank without crippling limitations, the strategy collapses into a series of short tactical hops lacking true operational depth. A heavy airlifter must lift heavy. The Y-20 could lift a tank in theory, but not in a way that served real strategic needs. Until the engine problem changed, the tank problem remained unsolved. Payload range reality. The moment a 58-ton tank rolled into the Y-20's cargo bay, the aircraft's most critical limitation came into focus. Every kilogram added to the hold forced a kilogram of fuel to be left behind, and with the D-30 engine struggling for thrust, the payload range curve didn't taper gently, it plunged. What should have been a strategic airlift platform suddenly became confined to short, cautious hops, its operational radius shrinking into a tight circle around the departure base. Crossing the Taiwan Strait, a distance that should feel trivial for a heavy transport, became a borderline calculation requiring minimal reserves and maximum optimism. Pushing farther, into the Himalayas or across the South China Sea, was simply beyond reach with a tank on board. The aircraft could not simultaneously carry the weight of armor and the fuel needed to conduct a meaningful mission. This wasn't a limitation planners could work around. It undermined the entire point of building a strategic airlifter. A heavy plane that can only move heavy cargo locally is performing a tactical role at best, a symbolic one at worst. And for a nation aspiring to project power rapidly, that gap between intended capability and practical reality was impossible to ignore. Until the Y-20 received real engines, China wasn't projecting power. It was negotiating with physics. China's escape plan. In March 2023, the Y-20 finally received the upgrade it had waited for since its first flight. The new WS-20 engine, a high-bypass turbofan developed in China, promised to drag the aircraft out of its underpowered past and into the realm of true heavy lift. On paper, the numbers looked transformative. Each engine produced roughly 31,000 pounds of thrust, nearly a 60% jump over the aging D-30s. With a bypass ratio approaching 5-to-1 or higher, the WS-20 pushed far more cool air around its core, bringing the efficiency and muscle a strategic airlifter demands. But the leap wasn't merely about thrust. The real breakthrough was metallurgy. To survive turbine temperatures above 2,000 degrees Celsius, the WS-20 required single crystal blades and advanced thermal coatings, technologies that took Western aerospace decades to master. For China, achieving these materials meant overcoming one of the steepest engineering barriers in jet propulsion. Without them, high power would come at the cost of reliability. With them, the Y-20 could finally aspire to haul a 66-ton load without sacrificing range. Yet capability on paper and capability in service are not the same. The WS-20 remains young, its reliability still being written in flight hours rather than projected in laboratories. While the upgrade theoretically places the Y-20 closer to the C-17's performance class, the long-term proof will come only through years of demanding missions, rough landings, and unplanned contingencies. For now, the Y-20 finally has the engine it always needed. Whether it can become the heavy lifter China envisioned still depends on time and endurance. If you want more deep dive breakdowns of military tech, hit like, subscribe, and turn on notifications. Tell us in the comments whether you think the Y-20 will ever match the C-17. And if you want the next episode to cover another aircraft comparison, drop your suggestion below.